So hello and welcome. We are talking about arithmetic progressions, and we are going to be looking at the first example, which I'm going to call a case 1 example. Okay, so remember what an arithmetic progression is. It is a sequence of the form, for example, 2, 5, 8, and 11. So I only really need 3 terms in order to determine a conjecture or determine if there's a pattern between the terms. So clearly the pattern over here from the one to the other is I'm adding 3 each time. And there we go. Okay, that is clearly what we call an arithmetic progression. Things could even get less. For example, if I had 2, minus 2, minus 6, and minus 10, then what is happening from the one term to the other is I'm subtracting 4 each time. And so you can see clearly I'm subtracting 4 over there, and clearly over here I'm also subtracting 4. And so these are all examples of arithmetic progressions. And how do I know it's an arithmetic progression? Well, I look at this number over here. This is what I call a constant first difference. Now, if you've already done the previous videos, you will notice that we also found second differences. In other words, the difference between these terms. And in this case, there's a constant second difference as well, but it is 0. And that's a trivial quadratic. We're not interested in trivial quadratic sequences. We're interested in sequences or patterns or progressions that have a constant first difference, such as the one that you see over here. So now the next question is, there you can see clearly that's also a constant first difference. Okay. What are case 1 questions? Well, firstly I need to tell you about Tn. Tn is going to be the general formula of A plus n minus 1 multiplied by D, right? And you already know the terminology referred to as n and Tn. N refers to the term position, while Tn refers to the term value. And then D and A, these refer to the difference between the terms. Okay, and for an arithmetic progression, we're talking about the constant first difference. And A, on the other hand, refers to the first term. So if I gave you a sequence and I said, determine the sequence that has a A of 5 and a difference of 4. We can just call it D of 4. Then you're going to tell me that sequence corresponds to the following. Corresponds to 5. The next term is going to be plus the difference, which is going to be 9. Then you're going to add the difference again, and you're going to get 13. And if you want to continue, you will tell me it's 17, and so on. Okay. Now there's a very special formula to determine the formula for this sequence, the general term of this sequence. And I'm going to show you what that is in a moment. If you're given that sequence 5, 9, 13, 17, we can say, okay, what's the difference over there? It's plus 4. What's the difference there? It is plus 4. What's the difference over there? It is still plus 4. And this gives you an idea that the constant difference is 4. So you already know for this sequence, D is going to be equal to 4. And if you look at this, you can say that A is going to be 5. And now you're going to say, Imad, well, that's quite obvious. You just did that in the previous step. Well, I'm picturing as if we were only given the sequence over here for the first time. Now we got to determine a general term. Now, what's a general term? The general term is basically a formula that you use in order to find any term of the sequence. In other words, you're going to throw in the position of the term. For example, this is in position 1. This is T2, term value in the second position. This is T3, the term value in the third position, and term value in the fourth position. What are we going to do? That's the key question. Well, let's see. I'm going to say, well, you can actually just take the difference multiplied by n, where n is the position. Then I'm going to say, well, substitute into that position. Put in 1. Substitute 1 in n. If you substitute 1 in n, then it's going to be 4 multiplied by 1, which gives me 4. Now you say, what must I add to this number or subtract from this number to get the very first term? Well, very good. You need to add 1. Okay, then you will get the first term. Because I substituted in 1, that corresponds to the first position, then I said what must I add or subtract to get the first term. And that's the method that a person uses when they are dealing with an arithmetic sequence. Now let's see, does this work? If I say 4 multiplied by 1 plus 1, what do I get? I get 5. And that corresponds to T1. What about T2? If I put in 4 multiplied by 2 plus 1, that gives me 9. 4 times 2 is 8 plus 1 is 9. What about T3? That's going to be 4 multiplied by 3 plus 1, and that gives me 13. And clearly you can see that this is working. Why don't you go and try it for T4, which gives me 17. Okay. Is there an easier way to do it? Well, we did this by means of inspection and a little bit of a trick. There is a general formula that a person can use. Now just remember this. Remember we've got 4n plus 1. There is another formula. The formula is for an arithmetic progression. It is Tn equals A plus n minus 1 multiplied by D. Now what is Tn? Well, Tn is the term value. What is A going to be if I go 1 back? And so let us look at this over here. Tn is equal to A plus n minus 1 times D. A in the previous sequence was 5 plus n minus 1 multiplied by D. The difference is going to be positive 4. And so I'm just going to put a bracket there and insert 4. Now you can actually simplify this. You can say, well, that is just 5. And then if I apply the laws of, distributive law, and I distribute that into that, I'm going to say it's 5 plus 4n minus 4. And if you simplify that, that's 4n. And 5 minus 4 is going to give me 1. Isn't that exactly the same formula that we got over here? 4n plus 1. This here is 5 plus n minus 1 times d. Now this is sufficient. In a matric examination, you are asked for the general formula or the Tn formula. You can just write out Tn equals a plus n minus 1 times d, substituting the d and substituting the a, and you will come up with this thing over here. You don't need to simplify further than that. You will get the 2 marks or 3 marks that is awarded for this part over here. Okay, so that's a basic introduction to sequences. Now, if I had to ask you, determine the 10th term for this particular sequence, all you'd say is, well, I'm looking for the term value at position number 10. And then I'll say T10 is equal to 4 multiplied by 10 plus 1, which is equal to 41. And there we go. Okay, that's an introduction to arithmetic sequences.